Hello, welcome to Indie Tutorials. My name is Guillermo and I would like to thank the Patreon supporting this channel. Today we are going to look at starting the foundations for our animation system utilizing Animancer, which is a Unity plugin which allows us to play animations on demand and control all of their details without any additional setup. It solves the major problem with animator controllers and can either replace them entirely or work alongside with them. This makes animations much easier to work with in all stages of development, from basic prototyping through the maintaining and debugging complex systems. We are going to be working in Visual Studio a lot today, so to save back and forth time, let's start creating the scripts that we are going to need today. And the first one is going to be a character script. So this is going to be like our hub containing all references to other systems. We are going to need a custom character Animancer component. Then we create here another folder and let's call this one states. Let's open up the folder and here we are going to create a new script and let's call this one CharacterState. The next one is going to be Locomotion state. And the last one for now is going to be called multi-state. There we go. Now let's double click on the CharacterState script to start writing the code. The CharacterState class is the base class that other state will inherit from. So in this case we can remove the seal key for abstract, so we are forced to inherit from this class, and then we need to change the mono behavior for a state behavior. Now if you click Ctrl dot, we get the chance to get the using statement for Animancer FSM, and after the state behavior we are going to implement this interface I own state of CharacterState. Okay, so it's complaining for something. We need to implement this interface. If we click Ctrl P again, we have the option to implement the interface, so let's leave it as it is right now and let's dig a little bit. So the state behavior is no more than a mono behavior from Animancer, but with some out of the box can exit state, can enter state, and on enter state and on exit state. That's all I got, nothing else. So it's just a simple bare bones of a state machine that we can use. Okay. The next thing we need here in this class is a reference to our character. So let's create a private field, character, and let's add a public field. with a setter for our private character. Okay. Now to implement this owner state machine, we need to create a finite state machine inside the character class, something that we are going to call here. So let's go and select our character script, and here in the header let's add using Animancer FSM, and then in here we can create a private read-only field of a state machine, and the type of this state machine is going to be our character state. We want to call we want to use in this state machine this with default, so it's a special type of state machine that requires to have a default state. In this case, in our case, it's going to be the idle state. This is our default state. So state machine equals new state machine character state with default. After doing that, we can go back to the character state script and remove this throw new not implement exception, and from here let's do character state machine. It's not saved. Sorry, my bad. This is public, not private. Okay, state machine. Now it's not complaining anymore. And we are done with the character state script. Now here in the character script, we might want this also to be used as a base class for enemies, NPCs, anything that could have animation finite state machine. So in that case, let's remove the seal, and here we need to add a reference to our character Animancer component. So let's create the fields, serialize field, Animancer component, and let's add a public field to expose it if in case we need it. We also going to need a reference to our character movement component, so let's add a serialized field, private character movement, public character movement to expose it. We are going to need a reference to our default state, which is going to be the idle state. So again, let's create a field, serialized field, private character state, and this one is going to be our idle. And let's add a public property for it. Now, since this character class is going to behave as a centralized group for all our reference to common part of the character and FSM. We want to instead of letting the character movement do direct communication to our state, let's use the character as a bridge. So here we need to pass to decide whether we want to walk or jog. We need the movement direction that we are receiving from the inputs. So let's create a move direction field that we can use then in our character states. It's going to be a public vector2, and let's call it movement direction is going to be a property, and what we want to return here is from the character movement our move direction, but we don't have it yet public, so let's create it here, move direction, and let's go back to the character movement script and open up. But to be consistent with the naming convention that we are using, let's create here a public vector2 movement direction, and this is going to return our move direction. So if we go back to the character script, we can change this one to movement direction. Okay. The final step here in the character script for now, so let's add some space, some room, is to call in the awake our default state. So since we can inherit or create child character from this class, let's add this protected virtual so we can override the awake method, making sure that we can then call this state machine default state is going to be equal to our idle state, right? So this is everything for the character script. So let's go now to the character movement. The character movement component or script is the one in charge of actually moving the player, and if it is the one that we want to apply the movement root motion movement. So for that we need to have a reference to our character Animancer component. So let's create a serialized field and let's call it private character Animancer component, or let's call this one just Animancer. And in case we need, we can expose a property to it. And we need a reference to our Unity character controller. And let's create a public property. Right. Now if we scroll down, we had here in the update method the transform position where we were moving the actual transform of the player using this speed velocity. So we can just comment this out for now. Later on we just delete this line, and we can find somewhere here in the script, let's say movement in between of moment on application focus. We can create our on animator move. So this is a script, a function that is called by the mono behavior when we want to apply the root position. So let's create a private void on animator move, and inside this function we want to create a vector tree to store the velocity we want from the root motion. Velocity is going to be equal to our Animancer component, and the Animancer component has an animator property. And from here we can call the delta position. Okay. We have this error because we haven't yet scripted the Animancer component. But let's just finalize here, and the last thing we need to do is from our character controller we need to call the move method and pass the new velocity. Okay, so now let's go to our character Animancer script. And simple enough, the only thing we need to do here is add the using Animancer statement and inherit this character Animancer component from the Animancer component, right? And we need to add a reference to our character. So serialized field again, private character, and the public property for it. That's it. So if we go back to the character movement, we see that we don't have that error anymore. All right. So let's start scripting our states. So let's select the Locomotion state, and we want this class to inherit from our CharacterState. We can remove the seal key, and we want to add the using Animancer statement here. Now this Locomotion state, instead of using a mixer state, which is like a blend space, we are going to use individual clips or animations, and we are going to use the clip transition for every of those, because that gives me the possibility to do a fade or crossfade between animations. So let's add the first one, which is going to be the idle animation. So serialized field, private clip transition, and let's call this one idle. And I will add a public clip transition property. Then we want also our walk animation. Walk. and the walk, and lastly our jog animation. Jog and jog. In this character state, in this locomotion state, in his on enter state, we need to decide which animation of these three to play. So let's override the on enter state, leave the base on enter state call, and here we can call the character reference, the character Animancer component, and we call the play. And here we need to pass which state to play. So let's create our logic here and call it current animation. So it's going to be a property clip transition current animation, and from here we want to get, and let's return by default the idle. So we can copy now this current animation and put it here, and do the same for the update. And what we need to decide here is, based on the move direction, whether we want to walk or jog. So let's do an if statement, and if our character movement direction is not equal to vector 2.0, we know by that we have input from the gamepad. We have the attempt to move. So now we can check the magnitude of this movement direction. And if it's below 0.98, and also the character movement direction magnitude is greater than 0, we want to walk. So we return the walk state. Else, if the character movement magnitude is greater than 0.99, we return the jog state. And that's it for our locomotion state. Let's continue with the last script, which is our multi-state state. And as well, this one needs to be inherited from our character state. And let's add here the using Animancer namespace. We can remove the seal key, and this multi-state is going to is like a special state that will hold several states at the same time. And think of it like, for example, handling all the animations when the character is grounded, even the jump. Well, in this case we don't jump, but we leap, or we need to sprint and then leap. But this script will handle all these animations that, for example, when we are grounded. Okay, back step, roll, and so on and so forth. So the first thing I want to do here is to make sure that this script is going to be executed before or after the inputs we receive. So let's add this default execution order, and instead of hard coding this, let's create a constant to store the value we want to put there. There we go, and let's put this constant over here, and we want to create here our list of character states. So let's add a serialized field, character state is going to be an array, states, and let's add a public property for them, character state states, and here we can add a nice information to the inspector. So this is the other states that this one will try to enter in order. After our property, we want to hold a variable with the current state we are playing. And then we are going to override the canEnter state, which is just going to pass the state to the state machine. So let's call override canEnter state, and from here we remove this and we pass character state machine canSet state, and we pass the list of states. For the exit, we can override the canExit state and pass that through, so we can always get out of this state. And in the onEnter state, we want to do something that allow us to go through all the states in this list on the update method from other scripts. So for that, let's remove this base onEnter state, and let's check if character state machine try set state. So if it's trying to set, the state machine is trying to set any of these states that we have in the list, we need to loop through all of them and set it. So current state is going to be equal to the character state machine current state, and we need to enable this state, which is at the end amount of behavior. Okay, so here we are trying to enter states, or we are passing the list of all the animations or states in this list, and internally we need to find a way to deal with the transitions between all these animations. So for that, we want this on enter state be conditioned by a flag that we are going to create over here. So let's call serialize field private bool auto internal transitions, and of course we make the public property. And then what we need to do is check here whether we have this flag or not. So basically, if this component was enabled via on enter state, due to this auto internal transition being enabled, it will use the fixed update to first disable itself, or disable this component if the character is no longer in the substate it entered previously. So let's add here a protected virtual void, if I can type fixed update. We are not dealing with rigid body, so we could get away by just using, I think, the update, but let's give it a try like so. So we have a specific frame to work with, and here we check whether if the current state is not equal to the character state machine current state machine. So if the current state is not equal, the current state here in this component is not equal to the character's state current state, then we disable ourselves and we get out of this function. Otherwise, we retrieve character state, new state, character state machine can set state. So we check if we can set any of the states in the list in order, and we return the state that was applied to the character. So if current state is not equal to new state, and also the new state is not null, then we set the current state equals to the new state, and we pass this state to the state machine. Force set state, and we pass the new state. There we go. So let's save the scripts and let's go back now to Unity. Alright, so after all that coding, now we can select our player character here, and let's start adding the components. So first of all, we need to add the character script. You can see now that in the character movement is already asking for a character controller and the Animancer character component. So let's add the character controller. Let's add the character Animancer component. The Animancer component needs to reside in the same game object as the animator. This is mandatory. So let's see. So we need to drag this character Animancer component to the Animancer slot in the character movement script. Then the character script need the Animancer and also the character movement reference, and then it's asking us for its idle state. So for that, let's add the hierarchy of the prefab. Let me remove this pivot icon, we don't need it any longer, and let's create an empty game object and let's call it states. So this game object will hold our multi-state component, which is already asking us to select a character or to add a character to it. So let's drag the player and to add the reference to the character. And also in this state we need to add our locomotion state. We can see here is the 3 animation clip we need to add, and as well it's asking for a character reference, so let's drag the player into it. Before adding the animations, let's go back to the player, and in the idle state let's select the states and drag it here in the idle. Because I have another plugin from Animancer or Cybernetic, I have the possibility to choose which of these 2 scripts I want to add. In this case will be the multi-state, and here in the character Animancer component is asking me as well for the character, so don't forget to add this one. And if we go back to the states now, we need to add the 3 clips. So I already prepared those. I have here animations, animation clips, characters, so I can add my idle animation, my walk animation, and my jog animation. Remember, those need to be with root motion, okay? Okay, so after adding the animations, we need to tick here out internal transition, and of course we have this state list which is 0 right now, so that let's add 1 entry, and let's select this locomotion state and drag it in this field. So if we now go to the player, make sure we are in focus, not full screen, and let's hit Ctrl P shortcut. We can see now that our character enters the idle state, and we can see it also here in the inspector. We got this multi-state error that we're going to investigate a little bit, but if I were to start walking, there we go, we walk and we jog. And I'm using the gamepad. If I switch now to the keyboard, of course, since we have 1 or 0, we jog, we go straight to jogging, which is the behavior that we expect when using the keyboard. Okay, let me stop play mode. And if we go to the console to see this error message, so it says that state behavior was already disabled before on exit state. If I double click that one, we go directly to the state behavior, which is the script from Animancer. And I think here in the multi-state, the problem is that we are disabling this game object or trying to access a state when this game object is already disabled. But I will investigate it deeper for the next video. It's a little bit long now, and we have successfully achieved our goal to use Animancer with actual root motion animations that we can use to start building our all complete animation system and movement set for this game. So on the next video we are going to start setting up now ORK Framework. So we are going to create our combatant and spawn the player the way it should. And yep, so thank you for watching, and I hope you liked the series and for supporting the channel.